This video is about mass spectroscopy of elements, which is a skill commonly seen in chemistry classes. This is the basic anatomy of a mass spectrum, where we have an x-axis representing mass and a y-axis representing percent abundance. By logic, all percent abundances that these bars represent need to add up to 100%. Each bar also has a number associated with it, which is called the mass number. This number is the sum of protons and neutrons in an atom for the element that the data was collected from. This number is also what you see in isotope notation. Let's look at how to do some problems with mass spectra, such as estimating the atomic mass. In this example, we have a mass spectrum here that is actually very precise due to all the detailed markings that we see here. That gives us the opportunity to use this formula to calculate the atomic mass of the element that this data was collected from. So what we do in this formula is that for each isotope, which is basically each bar, we multiply the percent abundance in decimal form times the mass number, and then that gives us our final answer. So for this bar over here, its percent abundance is about 1%. We convert that to decimal form. Its mass number is 84. And then for the next isotope, its percent abundance is 10%. And we're going to convert that to decimal form, which will be 0.1. And our mass number is 86. And when we keep going like that for each isotope, so on and so forth, we will have our final answer. For our second example, we have another graph. This graph is not as precise as the first one, and the markings are not detailed enough for us to be able to use the formula. So what do we do instead? Our first step is to find the tallest bar, which is 90 here. This is the most commonly found isotope of the element that the data was collected from. Next, we see where the other bars are placed on the mass spectrum, while all the other bars here are greater than 90. Next, for our third step, we estimate the mass. Seeing that most of the other bars, or in this case, all of the other bars, were greater than 90, but 90 is the most commonly found isotope, we can say that the mass is going to be a little greater than 90, and therefore the mass can be 91 grams. Thank you for watching, and good luck studying!